Good morning, first form, and welcome back to the summer term. Let's start our lesson today then. So can you please write today's date, which is Thursday the 23rd of April, and the title, which is Lesson 3, Solubility. The first thing I want you to do, please, can you remind yourself about the process of dissolving? We looked at this at the end of last term. There's a diagram here to help you. Remind yourself of the term solute. Solute is the substance which is being dissolved. Could be a solid, a liquid, or a gas. We've got the solvent, which is the liquid doing the dissolving. And finally, we make ourselves a lovely solution, which is a mixture, something that we can actually separate. Have a look at the diagram, check you understand what those terms are, and then I'd like you to complete the table of keywords in your books, please. Table drawn with pencil. Pause the video, please. So today we're going to have a look at the process of dissolving in more detail, and we're going to look at the solubility of different substances in water. So what I want to ask you first of all, you can try this at home. Can we keep adding sugar to the solution forever? Does it just keep dissolving? Does it seem to keep disappearing? What would happen? The answer is no. At a certain mass, the solution becomes something that we call saturated. That means that no more solute can possibly dissolve in the solution. Can you write that term in your book, please? What is saturated? You'll know when something is saturated because we'll start to see clumps of the sugar at the bottom of the beaker. They no longer dissolve. The solute doesn't dissolve. Write it down. Pause the video. We know that some solutes are very soluble. That means they dissolve easily, whereas other substances, other solutes, are insoluble, meaning that they don't easily dissolve. Sand is an example. We can easily measure how soluble or the solubility of a substance by seeing what mass of that substance dissolves in 100 ml of water. We always dissolve in 100 ml of water. We do that to make it a fair test. We can compare one substance with another in 100 ml of water, and we always do it at 20 degrees C. Here's some results for sugar, sodium chloride, which is salt, and calcium chloride. Think and write in your books, please, which substance is the most soluble? Explain how you know. Now we're starting to become familiar with this process of dissolving, and we said some things dissolve better than others. So for example, sugar is really soluble. It dissolves really well. Sand is insoluble. It doesn't dissolve. And we can compare the solubility of different substances using a solubility curve. So let's have a look at what this curve shows. First thing I want you to take a look at, please, is along the bottom, we've got something called temperature, and there's our unit degrees centigrade. And we're going up in temperature from 0 all the way to 100. Up the side, we've got the solubility, which to remember just means how well do we dissolve. And we can say how many grams of that substance will dissolve in 100 grams of water or 100 mils of water. Let's choose an example. I'm going to choose this one, K2Cr2O7. Doesn't matter what that substance is, but let's see what that curve shows. I can see as the temperature is going up, so as we go along the bottom, as the temperature is going up, the solubility is also going up. So as the temperature goes up, the solubility of K2Cr2O7 rises. Now you might want to be really fancy with your answer, and you could give some data. So I can say at 40 degrees, down at the bottom here, I'm going to get my ruler and I'm going to draw a line until I hit that purple curve. And then I'm going to go across. At 40 degrees, the solubility of K2Cr2O7 is 25 grams. Remember, I use my unit here, grams. Whereas at 80 degrees, I'm going to change colour now. At 80 degrees, if I go all the way up here, hit the purple line and go across, my solubility is around 58 grams. So my solubility's gone up. That's a solubility curve. Some curves are very curved, some are straight. Now this one's strange, it goes down. In your books, please, I'd like you to pick one of the substances here on this solubility curve graph and describe how does solubility change as the temperature increases. I've done an example for you. I've looked at the sample KCl. I've said as you increase the temperature, you increase the solubility of KCl. For example, and I've given some data. Can you please have a go? And if you're stretching yourselves today, we all should be, please, can you answer the question in the blue box? Now, we've touched on this term saturation already, and let's just remind ourselves, when there is a certain point in your experiments, you'll find that there's a specific mass of the solute where it cannot dissolve anymore, and we'll see, like in the diagram, clumps of that solute starting to form at the bottom of the solution. Just like a sponge, if we fill the sponge with water, at some point the sponge becomes saturated, no more water will fit in the sponge and it will drip out. So saturation is when you contain the maximum amount of solute that you can have within your solution. Our final and most exciting thing today then is that we're going to do a practical. Now we're going to investigate the effect of temperature on solubility. So the first thing I'm going to do is I'm going to tell you how to do the experiment. You're going to need to obviously draw a table ready for your results. You're going to carry out the method and get me some results, and finally conclude, summarise what you found. We're going to have a look at two things. We're going to do a beaker, although we don't have beakers at home, we'll have to use glasses, and into one glass we're going to put cold water, and into another glass we're going to put hot water, and we're going to compare how many spoonfuls of sugar we can add to each before saturation starts happening, so before we start seeing sugar at the bottom. So here's the method that I want you to do today, please, boys. I want you to get 25 mils of iced cold water, and I want you to put that into a glass in your kitchen. You can measure 25 mils with a measuring cylinder in the lab, but you'll have to use a measuring jug at home, or if not, use the same glass twice and mark on the glass where you go up to so you keep it the same each time. You're then going to use a thermometer to measure the temperature of that water, and you're going to record it in a table coming up in a minute. If you haven't got a thermometer, don't worry, you can just write down very cold. You're then going to add sugar. I'd use sugar rather than salt, it dissolves better. Very slowly using a teaspoon, and you're going to stir in between each teaspoon. So you add a teaspoon, stir, add a teaspoon, stir. You're going to stop adding when your solution becomes, our key word today, saturated. So when you start seeing sugar sinking at the bottom. And into your table, you're going to note down how many spoonfuls of sugar did you add until saturation. I'd then like you to repeat for warm water. Now you can do that using the tap. You can use the hot tap, please be careful. And then you can use hot water. However, do not use boiling hot water into glass. It will crack the glass and you'll get into a lot of pain there. So please make sure you mix always some cold water with the boiling water. Perhaps ask a parent to help. Before you carry out the practical, get yourself a pen and a pencil and write down your results table ready to go. So we'll have temperature in the left-hand side. Make sure you put your units in brackets, please. And then you'll have the number of spoonfuls of sugar that dissolved in that 25 mils of water. And then you can either write down the temperature if you had a thermometer, or you might write down in one column cold, warm, and very hot. And I'd like you to write down then what your results were in the practical. Good luck. I'd like you to now complete the practical, please. Take lots of photos. I want to see the work you've been up to and put them on the group. Remember to be safe. I know we might not have goggles at home, but we can certainly put some pinnies on in the kitchen. If you aren't able to do that, that's not a problem. Please just email me for results or ask a friend, and hopefully they will share those with you. Results table coming up. Copy it into your book and complete, please, in the next 15 minutes. To summarise then, we're going to do a conclusion. We call a scientific summary a conclusion. I'd like you to use the results that I got, please, or they're actually results I took from somebody yesterday, and I'd like you to take a look at them. So cold water, warm water, hot water, and boiling water. Can you answer questions 1 to 4, please, in full sentences in your book? So I'd like you to first of all describe what happened as the temperature went up to the solubility of the sugar. Pick 2 temperatures and give me some data. So don't just say as one went up, the other went up. Give me actual data. 3, why does dissolving happen more readily or easily at higher temperature? You might want to research or look that up. There's a hint word for you there. And finally, 2 other factors or things we can do to make the rate, the speed of dissolving go up. To finish then, please, can you mark your work in green pen? So first of all, I wanted you to spot for me as the temperature of the water increased, the mass of sugar or the number of spoonfuls of sugar which dissolved before saturation increased. It went up. You can see it going up here. I'm going to choose 2 bits of data. So I could say for cold water, only 2 teaspoons of sugar dissolved. However, for boiling hot water, 28 teaspoons of sugar dissolved. Give me 2 bits of data. Explain. Now remember, explain means why. Does dissolving happen more easily at higher temperatures? At a higher temperature, particles have more energy. Give yourself a tick if you use that word energy. So they're colliding. There's the next word I wanted to see. Colliding. Give yourself another tick if you got colliding. More frequently. Give yourself another tick if you got frequently. This means the solute particles break down and mix into the solvent particles more quickly. So imagine if you put sugar into a cup of water in hot water, it's going to get bashed up and dissolve quickly. So then the final thing I wanted, 2 factors that can change the rate of dissolving or the speed. You can stir and also particle size. Think about if you put a big sugar cube in versus very fine sugar powder. One would dissolve much faster than the other. So you can get here 1, 2, 3, 4, 5, 6, 7 marks, please. Please give yourself a mark out of 7. I'd like you to take a photo of your work and please send it back to me. Submit through Teams.